Hello class, in the name of God. As we explained in the previous section, we explained about EC and we introduced some EC comments and Darwin evolution. Uh, the EC is a branch of computer science that can solve some complicated problems that cannot be solved by some mathematic or some special solution. EC is a evolution or enhancement of solution. As we mentioned before, in the EC there is a fitness or evaluation function that evaluated the quality of solutions. Each time low quality solution uh, diminish, and we keep only the high quality solution for this next generation. Also, we have individual or solution. Individual refer to each solution. Also, we refer to the history of uh, evolutionary algorithm and Darwinian evolution and about the survival of Darwinian theory and the fitness of two properties or two features. We reach to this page and it referred to the population. Population is the collection of the solution. Each time in the evolutionary algorithm we have a set of solution, a set of individual. A set of individual referred to population. Population is a set of individual or set of solution, and we enhance or we increase the quality of this population in each generation. Uh, in this page, there is a genetic drift. Genetic drift refer to this. It is a idiom that refer that some gene or some properties diminish or vanish for the next generation by random behavior. Some properties of previous generation don't transfer to the next generation. It causes some problem, and it decrease the variation or diversity of population, and it causes the solution uh, provide the same for example offspring or son, and it caused this problem to have the same solution. All of the solution in the population are the same, and it causes the decreasing the diversity. And in the nature, each properties of parents transfer to offspring or to the children, and this code or this specification is called DNA, that meaning genotype. Genotype refer to this fact, the collection of gene in a, for example, in a man, in a animal, in the tree, in the flower. There are very some number of gene in the human, and the variety of this value of this gene cause the change in the, for example, face, in the hair, in the skin. Some human is tall, some human is short, some human have uh, black color hair, some human have uh, blonde hair, and the collection of gene is named genotype, but the human is collection of human is phenotype. We have a set from gene to human. It is called genotype. It is called phenotype. We don't have reverse way. We can't reach from phenotype to genotype. But the combination of gene provide a human with some specification. For example, black hair, black eye, yellow skin, tall, and other specification of human. And one gene may affect many traits, and many genes may affect one trait. A small change in a genotype causes a small change in the phenotype or organism, and it is referred to biology. But in this lesson, we have some idiom that are related to this biology, but we don't learn attention to the biology. It's not necessary to know for you to some biology or medicine idioms. And gene and genome. Gene are encoded in the chromosome. A collection of gene is a chromosome. A chromosome in the, for example, animal, in the human, in the vegetables, is a collection of gene. And in the computer science, in the EC, a chromosome is a solution, is an individual. It is collection of gene. So the chromosome is the same as solution. The solution is the collection of a small part of solution. Each small part is called gen or gene. There are some values for each gene. It is a genetic material. Genetic material is the value of a gene. In a human, there are 23 pairs of chromosomes from woman and from man. They combine together and cause some properties of offspring, some properties of children. In the human, each chromosome, for example, in the man have 23 chromosomes, and women have 23 chromosomes. They are combined into, for example, some specification of baby. Reproduction or product offspring from human is called reproduction or combination. Uh, we explain about some idiom of medicine or genetic, uh, but we don't explain it in the next sections. Only we use some idiom. For example, crossover. Crossover is the combination of the gene of parents. For example, uh, father have some gene, mother have some gene. Some of gene of father and mother mixed or combined together and caused a baby or a children. It is named crossover. Crossover. We can write shortly this. Crossover is referred to the combination of uh, some gene from parents. It is called crossover. We have crossover idiom in the EC algorithm. So each time we refer to the crossover, we refer to this fact that an individual or an solution with some gene or some small part of solution can combine to other small part or other gene, and these two genes cause a offspring or children, as you see in this page. An individual can cross over with other individual or father, and we can have some new solution or children or offspring. The offspring can have all of gene of father or all of gene of mother, or some gene from father, some gene from mother, and reverse. It may combination of one gene from father and other from mother, or some gene from mother, other from. It is a random combination, and it is named crossover. It is named crossover. Fertilization is the uh, produce children from father and mother, or from an animal. As we say, uh, children is a combination of properties of parents or father and mother. Uh, the gene of children or offspring, some gene is the same as father, some gene is the same as mother. But sometimes in children there is a gene that don't same, not neither to father nor to mother. There is a gene with specification that not exist in father, not exist in mother. Uh, it's called mutation or jumping in the gene value or genetic material. It causes new genetic material. In this slide, it explains about some medicine, and we don't attention to the medicine. It is about amino acid or DNA values. It is referred to this fact that the combination of gene cause a person or a baby, but we can't analyze or decompose the human to reach the gene. It's referred to this fact. As I say, the mutation is another operation in the EC or evolutionary algorithm. But in the genetic, mutation refer to the jumping in the genetic value. As I referred, sometimes children have a property that is not the same as father and it is not the same as mother. For example, both of mother and father have brown eye, but children have blue eye. It is a mutation. Mutation have a very low probability than crossover. In the crossover uh, with high percentage, the properties of father and mother transfer to the baby. But mutation have very low probability. For example, it is around 1 to 5%. And it is referred to this fact that in the crossover, some gene of father and some gene of mother, for example, here, produce the gene of baby. But one gene or some two gene, very small number, change by random. In the other word, we have, for example, two genes with a value that not exists not in the father, not in the mother. It is named mutation. Mutation is a process that cause generate new material or new value for a gene. In the other word, we may have some values in the gene that not exist in father, not exist in the mother. It is called mutation. Sometimes mutation in the nature cause some diseases or cause some problems. For example, a baby born with 6 fingers in each hand. It is not the same as father, not the same as mother. It is caused by mutation, but it is not okay. It is not desirable. But sometimes it causes desirable change. For example, I say the father have brown eye color and the mother have, for example, black eye color, but the baby have blue eye color. It is not bad, it is okay. Some mutation is okay, some mutation is not okay and cause better or worse offspring. As it is mentioned here, sometimes the specification of offspring. Offspring is mean children or child. Is not okay, and sometimes it is okay, but it caused by random. As I say, and we have a brain or some evolution mechanism that can improve the solution. In the computer, we have neurocomputer or neural network and evolutionary computing. This course refers to the second one, and evolutionary computing is a part of computer science that can solve some problem that cannot uh, be estimated by some special way, or such as differential equation or by mathematics. And it is a time consuming way. Evolutionary algorithm is not fast. It calls a long time, and it is increased. It can solve some problem with high complexity. Evolutionary computing is a robust, and it sometimes can reach a solution, an acceptable solution. It may not reach to the excellent solution, but always it can provide acceptable solution or robust. Robust is referred to this fact that evolutionary computing can solve the problem and can guarantee the reach to the acceptable solution, not the best solution. Sometimes it can reach the best, sometimes it cannot reach the best. We can divide the problem into the three groups. First group is optimization. Optimization is the problem that we know the model and we know the output, but we want to find an input to provide the best output in this model. For example, we have a complex function and we want to find the root of this function. For example, we have a function, for example, with this equation, and we want to find x. It is a model. Output is 0, and input we want to find an x that when put this to this formula produce 0. Finding root of equation is an optimization. Sometimes f is a error value. We want to minimum the error, or sometimes we want to maximum the precisation, maximum the accuracy. It is named optimization. Evolutionary computing can find best x by random, and it is a part of optimization. So EC is a way of optimization. Another problem is named model. Model is refer to the problem. We know input and we know the output, but we don't know the model. For example, we have a instrument that this instrument have some input and some output. We change the input and the output is changed. We want to have a model, for example computer model, that estimated the output when we apply input. We must define the model. It is a modeling. Modeling is another problem. EC don't related to the modeling. EC is a optimization, and the last one is simulation. Simulation is the problem that we know input and model that we want to find the best output. It is named simulation, such as some simulator. For example, we make a airplane simulation or simulator. The input is the, for example, the speed of wind, the humidity, the temperature, the gravity, and other specification of weather. Model is the model of flight, but the output is the interaction or action of airplane. We simulate the airplane. Evolutionary computing is not related to simulation, as we refer. So the EC is a branch of optimization. In the EC, we want to find the best input that provide desirable or excellent output. As I say, evolutionary computing that can solve the problem step by step, or it is referred to divide and conquer. Divide the question into some step, and each time it can solve each small part. It is named divide and conquer. So EC or evolutionary computing is a computer science part. It is a optimization way, and it can solve some complicated problem by divide and conquer. Divide and conquer is referred to the a small change of problem. Each time we solve each small change. This small change is the same as gene, and collection of gene is the same as chromosome or individual. It is a solution. It is a solution that we want to find it in the EC.